always a tough part of the 1-2 methods course is the further symmetry properties, and to a lesser extent the Pythagorean identity. So let's have a look at further symmetry properties first of all and see if we can knock it over. So if sine of theta equals 0.3, all right, yeah, let's draw that. All right, so we've got sine is 0.3, so that'd be about there. Should match up to there. Okay, so there would be our triangle, and let's just mark it. So that would be theta, and that is 0.3 because that matches up with that 0.3. Okay, and cosine alpha equals 0.8. All right, let's draw that one as well. So there's roughly 0.8. Okay, and that is alpha. Now it's not perfect, but what it's going to allow us to do is to visualize a few things. So this one was, what was it? The cosine of alpha. So that's 0.8 right there. All right, so what we want to find first of all is the value of sine of pi on 2 take away alpha. So that basically means we're starting at pi on 2 and we're going to go alpha degrees back this way. All right, so let's do it on this one where we've got alpha marked in. So we're going to start here, we're going to go back alpha. All right, so essentially that would be around about alpha there. So I'm just looking at that distance there. Let's see if we get something that looks reasonably correct. Right, so what I've done is I've started at pi on 2 and I've gone back alpha degrees. So there's alpha as well. Now, what you need to be aware of is that these two triangles are exactly the same. All right, so I've drawn exactly the same triangle. And so if I want to get for this question, first question here, sine of pi on 2 take alpha, all right, what I want to get is the sine, which is the y value. Okay, so I want to get this distance here. And if you notice that this triangle and this triangle are exactly the same, then this triangle moved into this place here would mean that that distance there actually has to be 0.8, which is exactly the same as that. Right, and we double check that the sign there is going to be positive. Yes, it is. So the answer to this first question is simply 0.8. That equals 0.8. Right, let's get the cosine of pi on 2 plus theta. Right, so what we're going to do is note that theta is probably, so we're starting at pi on 2, we're going to open up theta down there, which is, looks roughly the same. Doesn't have to be perfect. Roughly the same. Right, so there's my triangle. That's theta there, noting that that triangle and that triangle, they're the same. Okay, because that if that opens up theta and that opens up theta, then the triangle yielded will be exactly the same. Right, so what do I want to get? I want to get the cosine this time. Okay, so the cosine will be this value here. All right, so notice that we need the distance from 0 to there, which also happens to be the same as this distance here from this point to this point here. So these two bits, oops, that and that will be exactly the same. So the answer to this is going to be 0.3, but also note that the cosine value there will be negative. So this answer here is negative 0.3. Now, not everything is a pi on 2 and a 3 pi on 2 angle. So this one here, don't overthink this problem. This says sine of negative theta. So that means basically we're starting here at 0 and we're going to rock back theta, which means I would do something like this. Okay, so that is going to be theta there. It's the worst theta ever. All right, and what we want is the sine, which is going to be this value there, which is the same as this value. So this is going to be negative 0.3. Okay, so that question there, the last one, was just a similar question to the symmetry properties that you've been doing. So note the difference. The new symmetry properties are going to be based on pi on 2, or will get you to go from 3 pi on 2 and get you to draw a similar triangle. And you'll need to use the original triangle to work out what the values are going to be. All right, every year a student asks about this one. Okay, so if tan of theta equals 0.6, find tan pi on 2 plus theta. So we're starting at pi on 2 and we're going to go theta. All right, so whatever this is, that's how far we're going to go. All right, so let's have a look at this triangle here and note a few things. I'm going to draw this triangle rather large. That's 0.6. This distance here is 1. So I'm going to draw that over there. Let's just try it with a straight line. No, it looks roughly the same. Right, so we've got that being theta as well. Right, so what do we know? We know that that's 0.6. This length here becomes this length here, which is 1. Okay, and what we want to get is, in fact, this part here. Okay, because that is the angle that we're looking for. That's this part. So my suggestion is that you actually draw another triangle down here so that you can visualize this part here. Now that is going to be 1, that's going to be 0.6. And what we want is this angle here, which is given to us by going opposite over adjacent. So opposite over adjacent. So this one here is going to equal 1 over 0.6. Now one other thing to note is if this is what we're after, this line here, then it is going to hit the tangent down here. All right, so the next thing to note is this is going to be negative. Okay, so important to note that. So that's equal to negative 10 on 6, which is negative 5 on 3. So that's our value there, negative 1 1/3, which looks around about right. So just watch out for tan, that will cause problems, and when you get to it in the workbook, believe me, you'll have a question on it. So review this part of the video when you get to it. All right, the Pythagorean identity. All right, so just something to note about the Pythagorean identity. So let's just take a angle like so. Notice that that's 1. This value here is cosine x, and this one here is found by doing sine x. All right, and what we can do is piece it together using Pythagoras' theorem, which is, remember, c squared equals a squared plus b squared. Okay, and in this case here, what we've got is the hypotenuse, so 1 equals sine squared x plus cosine squared x. Now, note the interesting notation there. So this is the equivalent to sine of x all squared plus cosine of x all squared. This notation is also acceptable. This is the more common one that you'll see. Okay, so this doesn't mean square sine and then multiply by x. This is actually meaning sine of x all squared plus cosine of x all squared. All right, so that's the Pythagorean identity. Is it actually given to you? Curious the notes have it. No, they don't. So yeah, that's the Pythagorean identity. Okay, so 1 equals sine squared x plus cosine squared x, or sine of x all squared plus cosine of x all squared. All right, so given that sine x equals 3 on 5, and we've got an angle between pi on 2 and pi, find cosine x and tan x. All right, that's cool. So sine of x is 6/10, and we're in the second quadrant. All right, so that's 6/10 roughly there. All right, so let's draw that in. All right, so the sine, that value there is going to be 3 on 5. This value here is going to be 1. And this value here is what we're after. We're after cosine x. So what we can do is pop this into into Pythagoras' theorem to work out this length here. So we can say that we've got c squared equals a squared plus b squared. 1 equals this one here. So we'll go 3 on 5 all squared plus b squared. All right, now what we're going to do is note that this is 1 equals 9 over 25 plus b squared. Let's subtract, which is 16 over 25 equals b squared. And we're going to note that b equals plus or minus 4 on 5. Okay, so that's this measurement here, 4 on 5. Right, so therefore cosine x is equal to plus or minus 4 on 5. But what do we note? We've got, but x is an element between pi on 2 and pi. Therefore, cosine x is equal to negative 4 on 5. Now, why did I know that? Because this is the domain of x, and have a look, cosine. It's negative. It's got to be negative 4/5. It can't be the positive. Right, so there we go. We've got cosine of x is equal to negative 4/5. Right, and the last one we want to get is tan x. Now remember the rule for tan x. Tan x is equal to sine x on cosine x. Sine on cos. All right, now again, why is that? Because circular functions, tan is equal to the opposite over the adjacent, sine on cos. All right, so what we can do is just pop those in. So we've worked out sine x, or it was given to us. That one was 3 on 5. And we just worked out the cosine, negative 4 on 5, which is equal to 3 on 5 divided by negative 4 on 5, which is equal to 3 on 5 times negative 5 on 4. They cancel out, leaving us with negative 3 on 4. Just to see whether that makes any sense. All right, so it's definitely going to hit the tangent at a negative. That looks a little bit lower than 0.75, but hey, I've hardly drawn this thing to scale, so I'm pretty confident that that's right. So there's the Pythagorean identity. Now we've got 2 things to go through today, the worksheet 1 identities task and exercise 14K. So not many questions in 14K supplemented by this first worksheet.